Hi, Adriana. Thanks for your question. Sorry to take so long to get back to you. Um, I've attached a URL for a Khan Academy video that does a really good job of explaining the linear combinations of vectors for you as well. So if after I'm done here it doesn't 100% make sense, then try having a look at that as well because he's really good and I think you'll understand it quite well watching that. So if we're going to prove that V is a linear combination of vector u1 and vector u2, then all that means is that we're multiplying some scalar, some scalar c1 by vector u1 and another scalar c2 by vector u2, okay? So it doesn't even have to be c1 and c2. You can use a and b, and that might even be easier. So what's going to happen is we're going to go across the top for the x values. You're going to end up with like 1a plus 2b has to equal 1 because that's what we would get in vector v. The second equation would come from the y values in these vectors, so you would have minus 1a minus 1b equals 2. So what you've got now is a system of linear equations in two variables. We can actually solve this one using elimination back from your high school days when you used to line these guys up and add them or subtract them to eliminate one of the variables. So we have 1a minus 1a here, that makes 0a. And if we have 2b plus minus 1b, we get 1b. And if we have 1 plus 2, we get 3. So that's a really easy solution there because it tells us already that b equals 3. If I go back into the original, into the first equation, and I just substitute b in there, then a is going to be, sorry, that's a 6. I'm thinking forward to the final answer, minus 5. And so if I can find a combination, in other words, this one says that minus 5 times u1 plus 3 times u2 equals v, or equals the 1, 2 vector there. 1, oops, 2. Didn't mean to put that line in. Let's take it out. Okay, so 1, 2. Okay? So that's what you're trying to achieve, is you're really just solving a system of linear equations when you're trying to prove this for the span and for the linear combinations of vectors, okay? So for R2, if we're working in two dimensions for 1 and 2, questions 1 and 2, that's how you can do it. And you can use your old-fashioned elimination or substitution methods to solve for A and B if they exist. Now for 3 and 4, because we're working in 3 space, you can create your equations, but you're going to get 3 equations with 3 unknown variables. And so we have to move to a matrix to solve. So if we do that, I'm going to set up number 3 for you in a minute here. If we do that, then you're going to have to use the Gaussian-Jordan elimination to bring it down into the reduced row echelon form with the 1s down the diagonal, and then you can solve for your scalars A, B, and C. All right. So if we were looking, let me change colors here so we can keep track of what we're doing. If we were looking at question C, what we're being asked to set up here is some scalar A times vector u1 plus some scalar b times vector u2 has to equal vector v, which is 1, 2, 3. So the equations that are going to come out of that are 1a plus 0 equals, I'll put the 0 in, equals 1. And then we've got a plus b equals 2. And 0a plus 1b equals 3. Aha! That one's easier than using a matrix, isn't it? Because we already have a value here, a equals 1, and a value here, b equals 3. And so we do have a linear combination here without actually having to create a matrix. So that was nice. The reason for that is that they chose numbers using zeros. So we've got zeros in number 4 and zeros in number 3, and that's actually going to allow you to find A and B if they exist, okay? So question 4, when you do that, I suspect they've got one in here that works and one in here that doesn't work. So I think probably with question 4, you're going to end up with A equals 3, B equals minus 1, and in the middle we would have 3 minus 1. Yeah, no, it works as well. Okay, so you can do number 4 exactly the same way as number, why did I say C? Number 3. There we go. So hopefully that helps. And again, the URL for the Khan Academy video also might be helpful if you want to just kind of strengthen your understanding on this topic.